Hi everyone, I welcome you to this lesson on finding the exact areas between the two graphs. I'll be solving one example by hand and most of the examples by CAS to save some time. So let's get started. We are looking at a GeoGebra resource, and in this I'm going to explain the concept behind finding the area between the two graphs. The red line, the darker red line, can be assumed as a strip of infinitely small width. Dx. So the width of this strip is very tiny and it is infinitely small dx. Now the next thing remains is to find the height of this strip. The height of this strip can be found by writing the coordinates of this strip. The, uh, the upper function is the function of line, that is u of x is x plus 2, and the lower function is given by x squared, the parabola. So the coordinates of the lower point will be x comma x squared. So this is how you write the coordinates only in x. So to find the height of this strip, we need to understand the coordinate geometry. So this will be our upper function x plus 2. So the height from the x-axis to the top of the strip will be x plus 2. The height of this strip, the lower part of this strip will be v of x, that is x squared. Therefore, the height between will be the upper function minus the lower function, or that will be equal to x plus 2 minus x squared. So we have found the width of the strip, which was dx, and the height of the strip as ux minus vx. If we multiply them together, we find the area of this strip. So let's write the area of the strip, and that will be equal to the upper function minus the lower function, that's the height of the strip, multiplied by dx. Now, in order to find the area, the shaded area, we need to add the areas of these tiny, tiny strips all the way from -1 to +2. So in order to do that, we need to integrate. So integration means to combine, to add, to join. So all of these are the meanings of integration, to sum basically. So the area of the shaded portion, not the strip this time, it's a shaded portion. We need to add all of the areas of the strip from -1 to 2. And this will be u of x minus v of x dx. And that's what they have done here. So we integrate this and then we'll be able to get our area. So at the moment, the x value is 0.87. So we are getting the area from -1 to 0.87, and that is 3.06. Now let's explore this further. So I'm erasing this. So this strip will shrink and grow given the position of x values. But anywhere the height of the strip will be the upper function minus the lower function. The upper function minus the lower function. The upper value minus the lower value. Upper value minus the lower value, and so and so. So it will be given by the x plus 2 minus x square. And if we add them all the way to 2, from negative 1 to 2, the area comes out to be 4.5 square units. Now let's check if this is correct and also try to understand, develop the formula. For this, I'm going to use my calculator. And we know that our upper function is x plus 2, and our lower function is x squared. After that, find the height of the strip. We'll write a height function for the strip, and let's say this is h of x, and that is the upper function minus the lower function. Always upper function minus the lower function. And we have defined the height function. Many a times a question comes in the exam where we have to find this height function between the two graphs and how to maximize it. So please understand this concept very carefully. After that, if we were to find the area, we need to use shift plus, or we can use the template and then click to this button. Then we need to find the area from negative 1 to positive 2. And we have to write h of x, which is the height function of the strip, multiplied by the width of the strip, which is d of x. So if you multiply the height function with the d of x, we should be able to get the area. And it comes out to be 9 over 2, and which we had found earlier. That 4.5 is 9 over 2. Now let's explore this further by doing some examples. So in this question, we are given a parabola, and then we have to find the area between the line and the parabola. We need to clearly understand, define the upper function, and this is the upper function, because to find the shaded area, this is the shaded portion or shaded area. So this is the upper line, that's why it's upper function. This is the lower line or lower function. So that's why we'll write this as L of x. And the height function will be given by u of x minus L of x. And then we need to find the area from negative 3 to 0. And that will be our area. So calculate the area with the help of the given information. So we need to and the area comes out to be 27 over 2, but I think we need to change the limits. We have not provided the limits here. So let's write down the lower value is -3 and the upper value is 0. So in order to calculate automatically for the other graphs, we'll just use lower and upper variable names. And this gives us the area of 33/2. So this is how we calculate the area between the two graphs, where one of the graph was given as parabola, the another graph was a line, and then we have to find the area between -3 to 0. Let's see if this is correct. And this is right. So now let's do another example, and we'll use the CAS calculator to find the area. To find this area, we'll have to find the point of intersection. So fortunately in this graph, the point of intersection is given as 4, 4. And it is from origin 0, 0. So the upper graph is the square root graph, which is u of x. And the lower graph is a parabola, which is v of x. So all we have to do is u of x minus v of x from x is equal to 0 to x is equal to 4. So we only need the x coordinates. So we need to find from there to there. Because our length of the strip will be from there to there, and the height of the strip will be equal to u of x minus v of x. So the integral that we need to use is from 0 to 4, and u of x is 2 square root of x minus, and we need to integrate from 0 to 4. So let's use our calculator. Upper function is 2 times the square root. So control this will give us the square root. Pressing enter to accept. The L of x is x square over 4. And our lower value is 0. And the upper value is 4. And the area between the two functions will be 16/3. Now let's see if this is correct. And it works. Now in this question, we have to find the area trapped between the two graphs. So for this, we need to form the integral. So there are two areas here. So this is our area number 1, and this will be our area number 2. Because for this portion, the area 1, this is the upper function, and the lower graph is the lower function. But the same graph after this point of intersection becomes the upper function, and the other graph becomes the lower function. So we have to calculate these areas in two parts, area 1 and area 2. And this is important. From the geometry and the graph that's given to us, these graphs are intersecting at -3, -3. So therefore, we need to write our area 1 will be equal to integral from -5 to -3. So that x value there is -5 and this x value is -3. So therefore, we need to integrate from -5 to -3. The upper graph is this graph, and I'm just trying to figure out that should be our this graph. So what we need to do is x square over 2 plus. And from that, we need to take away the parabola function like this. And this will be our area 1. Now to find the area 2, the upper graph will be x squared plus 6x plus 6. And this we need to integrate from -3 to 0. So this is x is equal to 0 there. So we need to calculate from -3 to 0 minus the lower function, which will be and then finally we need to add them together. So total area will be, and that will be our final answer. Now let's use our CAS calculator to do this efficiently, save some time. So in our calculator, we are going to enter the upper function and the lower function. And the lower function is x square over 2 plus x minus 9 over 2. So we have entered the upper and the lower function. And then h of x will be u of x minus L of x. And the lower value we can write for the first area will be -5. And the upper value is -3. We can also write them as A and B. So I think that's a good idea so that we don't get mixed up with the lower and upper functions. And then after that, we have to update this as A to B. And we find the area of the, so the area came out as -8 over 3. So this is a little doubtful because usually the areas are positive. So it's because I think we have assumed the upper function as x squared plus 6x, which is not the case. So therefore, this is we need to make it positive, and it will be 8 over 3. So our area A1 came out as equal to 8 over 3. Sorry, it seems like the XP pen is not working. So what we need to do is we need to write this as equal to minus 8 over 3. That makes it 8 over 3. And then we need to calculate the second area. And the second area will be from a equals to negative 3 to 0. So negative 3 to 0. And this time also you will get a positive or negative. You have to convert to a positive area. That makes it 27 over 2. So 8 over 3 plus 27 over 2. And when we plus them together, that will be our total area. I think that should be our answer. Let's see if this is correct. And it is correct. Now let's get to the next question, in which we have to find the area trapped between the truncus graph, the y is equal to minus 2. So this is super easy. So all we have to do, we can even do it by hand. So let's do it by hand. So our area A1, and that area A1 can be given by the upper function, which is truncus. So that is 1 4 over x squared. And then from that, we take away the lower function, which is y is equal to minus 2. So it's minus 2 times dx. And we need to calculate this from 1 to 3. So this is 1 here, x is equal to 1, x is equal to 3. So we want to find this area. So the strip is this here, and the strip will go from 1 to 3. And we need to find from 1 to 3. And that will be 4 times x to the power minus 2. So just cross-checking one more time if I have made any mistake. I think that should be the area. So let's see if this is correct. So that's right. Now let's get to another example in which we have to find the areas. So in order to find these areas, we need to divide them into two areas, one area A1, area A2. It's very important that we have to divide them, split into two areas because of this point of intersection where the upper graph will now become the lower graph and so on. So that's why we need to change this. So due to the graph, the point of intersection is already found as x is equal to 2. But if not, then we have to calculate the x-intercept of this parabola with the help of CAS calculator. Now our integration will be the area A1 will be equal to integration from 0 to 2, and it will be negative x square over 2 plus 2. That's the parabola, and multiplied by dx. So that will give us the area A1. Similarly, we can find the area A2. That will be this time, that will be our line and the parabola. So the equation of the line will be, and this area will come out to be a negative area. So this will be a negative value, and area A1 will be a positive value. So in the same way, we can find the area A2, and what we have to do is from 0 to 2, no, not 0 to 2, but 2 to 4 this time. And we need to do is, and this will give us the two areas, and then we have to add them together to find the total area. Now let's use a CAS calculator to solve this efficiently. So the area of the parabola, so sorry, the function of the parabola is and the lower function we have defined as this. So upper function is 0. Y is equal to 0. That's the x-axis. And the value, the lower value, the a will be 0, 2, 2. And the area came out as 8 over 3. Now for the second area, the area A2 will be from 2 to 4. So need to do is 2. The graphs are going to remain the same, but it's 2 to 4. Comes out to be 16 over 3. So therefore, the total area will be 8 over 3 plus 16 over 3 makes it 24 over 3. So it will be 80 square units. And that is correct. In this next example, we have to find the area trapped between a cubic function and a parabola. And I will try to solve this without the help of the graph, but if a graph is given, certainly it is very helpful. So in order to solve this with the CAS calculator without the help of the graph will be, so we need to find the point of intersection. So we'll need to add a calculator page. And let's define these functions because we have to define them. The upper function we can choose to be a cubic function. Let's choose this to be cubic functions minus. And the lower function will be minus x square over 2. After that, with the help of calculator, we can find the points of intersection. So for this, we need to use the solve command. and then we need to write u of x is equal to f of x, lower function. And then we solve for x to find the x-intercepts. It comes out to be -2, 0, or 3. And they are exactly right because you can see that this is x is equal to -2 and this is x is equal to 0 and this point of intersection is at x is equal to -3 comma something. So therefore these are the 3 points of intersection where the x coordinates are -2, 0 and 3. Now we need to write the integrals and find the areas. So we need to find the areas from -2 to 0. So that is -2 here to 0. And that area came out as 8/3. So this area is 8/3. Since the areas cannot be negative, so therefore we have to make them positive. So it came out -8/3 because the y value, the strip, you can see that strip there. And also probably it's because that cubic function was a lower function. We have defined that as a upper function. I think that's the main reason. So because we have defined the cubic function as an upper function, but in this situation it is a lower function, that's why the area came out as negative. And this area is 8/3, so we have to make this positive to 8/3. After that, we need to find the area, the second area that is from 0 to 3. So for that, we need to change the value of a and b to 0 to 3. And we get this area as 63/8. And when we plus them together, we get the area is 253/24. Now let's see if this is correct. So for that, we need to go and check, and it looks correct. The second thing I wanted to say is that on the CAS calculator, if you were to find with the help of graphs, you can find that. So what we need to do is go to the doc, insert, and graphs. And then we just have to type u of x. And let's say we draw this graph from -2 to 3 because the rest of the portion is not necessary. So -2 is less than equal to x is less than equal to 3. And we have got this graph, the cubic function. Now press the tab and then after that L of x, the lower function, which is also from -2, and we get the graph, this parabola. Now if we were to find the area trapped in between these two graphs, I don't know how to do it, but let's see if we can. So bounded area, yes, that's a great command. Now, once you see this selection line, what you can do is you can say start typing -2. So when you type and it opens up automatically a text box and press enter. So that means from -2, now we need to find this to 0. So press 0. So when the command is active, just press 0. Don't press anything else. Press enter and you will be able to get the area between the two. That is 2.67. Now we use the command again. So menu, analyze graph, bounded area, and we press 0, 2, 3. And we get the area of 7.88 and then we can join them together. Now let's try if we can get the bounded area without in two steps, in one step. Let's see if we can get this bounded area in just one step. So we go to menu, analyze graph, bounded area, and let's say we want to find the area from -2 to 3. And that gives us 10.5, and certainly with the help of just one step, we can calculate the area. But the problem with the graph page is that it always gives you the values in the decimal. You can't find the exact values. To find the exact values, you have to use the calculator. So this is how you can find the bounded area between the two graphs. A few more examples are given in which I would like you to explore. I think this example is not from the VCE. So you can try this one where you have to find the bounded area between the two graphs and the x values are from -pi to pi/2. So let's try with the help of CAS calculator if we can do it. So the upper function we can define as a minus cos of 2x minus 2 cos of multiplied by. These calculators are very sensitive about multiplications. Please multiply, multiply, multiply. So that is cos of x. Enter. After that, we say is cos of x. So this is ux minus lx is fine, and this is minus pi and pi/2. Sorry, I think gotten out of the math box. So to type it again, and we need to delete this comment. And that gives us an area of -3. But this will include the negative areas and so on. So this is not correct. We need to do is from -pi to pi/2. So that means it has to be -pi to -pi/2 first. And that gives us an area of 3. So that means this is an area of 3 there. And then we need to find the other area from -pi/2 to +pi/2. So -pi/2 oh, so -pi/2 to +pi/2. I beg your pardon, I'm using lots of programs to make this tutorial, so there are mistakes. So that is equal to 6. So when we add them together, the area should come out to be 9. Let us see if this is correct. And also you can see that in the calculator, the graph will be automatically drawn, but not to the way we wanted because the limits were defined different. So pressing tab, and then we need to change these limits to. So the upper graph is from -pi to pi/2. So -pi And the lower graph, which is so negative pi to pi over 2. And this time it looks perfect. And now what we need to do is we need to find the integral again. So let's delete these points. Bounded area, and from negative pi to pi over 2. Sorry, I think didn't. And that comes out to be in 8.99 or 9 because I think my point is a little bit out there. But that point, if I can move it to exactly at 9, exactly at pi over 2, it will be exactly 9. So this is how you calculate the area trapped between the two functions. Even in the trigonometry works the same. Now let's look at the next question, and I leave this question for you to complete. The answer to this question is here. And I think that's all in this lesson. So I thank you very much for joining and see you in the next lesson. Bye.